Okay, welcome back. Let's just finish taking up these two here. So, with C, what I did is I had this whole bracket here, 81 x to the exponent 8 was all the exponent of 3 over 4. So what I did is I applied the exponent to both the 81 and the x to the 8, and I can do that again because these two this one term is a coefficient and a variable part that's multiplied together. I wouldn't be able to do that if those two things were added together, but since they're multiplied together, I can apply the exponents separately to the 81 and to the x to the exponent 8. So in that case now, I'm dealing with the 81, the exponent 3 over 4, and x to the exponent 8, again, all the exponent 3 over 4. So dealing with each of them separately actually makes things a little bit easier. So with the 81, I can go straight to expressing that in radical form by having the fourth root of 81, all the exponent 3. And with the variable part over here, I have power of a power, so I'm going to multiply those exponents, 8 times 3 over 4, which is what I'm doing over here. Okay, so take that a little bit further. Now the fourth root of 81 is going to be equal to 3. Okay, and 3 cubed is going to be equal to 27. As for the variable portion, if I multiply the exponents together, 8 times 3/4 gives me 6, so I wind up overall with 27 times x to the exponent 6. Okay. With D, I'm sort of combining parts of B and C together, so I have both a coefficient and a variable here, and there's a negative exponent. So first things first, I mean, you don't necessarily have to do it in this order, but I would apply the negative exponent first and just change it to a positive exponent. So I put that into a denominator, so 1 over 243x to the exponent 5 to the exponent of 2 over 5. And then doing what I did in C, I apply the exponent separately to 243 and to the x to the exponent 5, and work with each of them separately. So the fifth root of 243 all squared, and then x exponent 5 all times all the exponent of 2 over 5, which means I multiply the exponents. So for the x portion, 5 times 2/5 is just equal to 2. Okay, pardon my error right there. 5 times 2/5 is 2. And the fifth root of 243 is 3. And then 3 squared is equal to 9. So the final answer should be 1 over 9x squared. Okay, so again, as you can see, this gets a little bit tricky to work with, especially with all the radicals, and we have negative exponents in there. It can change things up a little bit, so it just takes lots and lots of practice. Okay, so let's do a few more before we call it a day. So let's take a look at these situations here. So these want you to simplify first if possible before you evaluate. So I don't want you just blindly throwing everything in your calculator and telling me an answer. I would require you on a test to actually show the simplification before you got to the evaluation step, just so I know you know the steps, rather than just knowing how to punch numbers in a calculator. So in the case here, I have 81 to the exponent of 11 over 4 divided by 81 to the exponent of 7 over 4. How can I simplify that? Well, again, I'm dividing two powers of the same base here. So when I divide two powers of the same base, I subtract the exponents. This is going to be the same thing as 81 to the exponent of 11 over 4 minus 7 over 4. Okay, again, just subtracting those exponents. When I subtract those exponents, 11 over 4 minus 7 over 4 is 4 over 4, which of course is just 1. So 81 to the exponent 1, which is just 81. Okay, so you see it already becomes a lot easier when you can simplify it first, right? You're not dealing with a radical over here and a radical over here. You simplify it first, and then you never know what's going to happen. Okay, so in the case of B, I have two powers at the same base. The base is, in this case, 25 over 36. I'm multiplying them together. So I'm going to multiply them together. I'm going to add my two exponents together. So this is going to be 25 over 36. I'm going to add my exponents. I'm going to get 2 over 5 plus 1 over 10. Okay, so remember, to add exponents, I find a common denominator. So 2 over 5 is the same thing as 4 over 10. Okay, so that gives me 25 over 36. And the exponent is 5 over 10, which of course reduces down to 1 over 2. Okay, so now how do I apply this exponent of 1 over 2 to a fraction? So remember, when I have a fraction that's all to an exponent, I can apply the exponent to both the numerator and the denominator separately. So this will be the same thing as 25 to the exponent of half, all over 36 to the exponent of half, Okay, and now using my rational exponent rules, the 25 to the exponent of 1/2 is the same thing as the square root of 25. And down here I'm going to have the square root of 36. So both of those I can evaluate, and I get 5 over 6. Okay, now I'll do C before I let you try the last two on your own. So with C, now here I'm adding two powers to the same base. So if you're thinking to yourself, well, what's the rule for adding two powers to the same base? You'll be thinking for a very long time because there is no rule. Okay, so in this particular case, there's nothing you can do to simplify first at all. That's why it says, if possible. This time you can't simplify it first. So your only course of action here to evaluate this is to work out each of these separately and then, of course, add them together. Okay, so now what we can do is we can convert them each to radical form. So the first one here is going to be the 4th root of 81 all to the exponent of 11. And the second one will be the 4th root of 81 all to the exponent of 7. Okay, so the 4th of 81 you can figure out that's going to be equal to 3. So I have 3 to the 11 plus 3 to the 7. Okay, and I don't expect you to have 3 to the 11 memorized. You can use your calculator for that. So work both these out in your calculator and add them together. Okay, 3 to the exponent of 11 is 177,147. And 3 to the exponent of 7 is 2,187. So overall, when you add them together, you get 179,334. Okay. So, two more to try in this lesson. I want you to give them a try on your own first. You might have to think about them a little bit here, because you see this one's a little different. There's decimals now. What are you going to do with those? And this, of course, has negatives in it, which again might make you think a little bit harder. So try doing it on your own first, and when you have them, push play and we'll go through them together. Okay, so let's take a look at D first. Now, the thing that you have to be careful of is in both of these cases, the minus signs there are not part of the power. Why? Because they're not in brackets. So the way it's written, only the 225 is the exponent 3 over 2, and here only the 16 is the exponent 3 over 2. If you had something like this with brackets around the negative 225, then the negative would apply to the power 3 over 2 as well. But they're not, so they're not part of that one. So it just means when you start changing from having rational exponents to having radical form, that negative needs to be left out of that whole thing until it's all evaluated. So here I leave the negative out. 225 to the exponent of 3 over 2, so again the 2 means it's a square root. So square root of 225 all to the exponent 3. Okay, for the 16s, the square root of 16, again all to the power or exponent of 3. So the square root of 225 is 15, and 15 cubed is 3,375. Square root of 16 is 4, and 4 cubed is 64. So you get negative 3,375 minus 64, which gives you that there as a total. Okay. As for E, what made E quite tricky, number one, there was negative exponents involved, okay? And B, there was decimals involved in terms of the exponents. So first I dealt with the negative exponents, and what I wanted to do there is I just moved everything with a negative exponent over to the other side of the fraction. So if it was in the denominator, move up to the numerator. If it was in the numerator, move down to the denominator. Again, I can do this as long as everything's multiplied or divided by each other. If there's addition, subtraction going on, I couldn't have any movement moving up or down that fraction. So then for this first line right here, you'll see the 625 to the exponent 1.75 is staying put. Okay, but the 125 to the exponent of 2 over negative 3, which is the same thing as negative 2 over 3, moves up to the numerator and becomes a positive exponent. And the 25 to the exponent of negative 1.5 moves down to the denominator and becomes a positive exponent. Okay, so that took care of the negative exponents. The next thing I had to worry about was those decimals. I had to convert those decimals into fractions. So as a little bit of review, 1.75 in fractions is 1 3/4. Okay, and 1 3/4, remember to convert from mixed fractions to improper fractions, it's 4 times 1 plus 3, so it gives me 7 over 4. Okay, as for 1.5, 1.5 is 1.5, which is 3 over 2. So then I changed my exponents here to having fractions. And once all that's done, I'm off to the races. I can start converting to radical form for each case. and then evaluating from there. So 625 to the exponent 7 over 4 is the fourth root of 625, all to the exponent 7. For the red one here, I get cube root of 125, all squared, and down the denominator I get the square root of 25, all cubed. So the fourth root of 625 is 5, and so is the cube root of 125 and the square root of 25, so you have 5s everywhere. So you have 5 to the exponent 7 times 5 to the exponent 2, all divided by 5 to the exponent 3. And what I did from there is I simplified using my exponent laws. So here I'm multiplying two powers of the same base, so I add the exponents, so I get 5 to the exponent 9 over 5 to the exponent 3. And then here I'm dividing two powers of the same base, so I subtract the exponents, so I end up with 5 to the exponent of 6, which is 15,625. Okay, so a lot was going on in these last few examples. Okay, and like anything, it just takes lots and lots of practice, so don't avoid it just because you don't like it or it seems boring. You need these skills going forward for whatever math course you take. If it's 3U next semester, or if it's 4C next year, or potentially even data management, you're going to need to work with exponents. So please do the practice. Get help as soon as you possibly can if you need it, and we'll go forward from there. Okay, so that's it. That's all, and hope this worked out okay.